E of x, how we are getting? Sigma, because we need to take after calculation according to arithmetic mean, we need to multiply first. Now we are not multiplied. Till now we are not multiplied with the respective frequency. We are just finding the value for 2x minus 4 and x square value. There are three possibility for getting a head, at least one head. So there is no head one time, which is non-appearing head. Hello everyone, a warm welcome to one and all. I am Natesh, lecturer in Commerce, Vidhyaashram First Grade College, MYSURU, the Temple of Excellence. We are in the Unit 3, Section 6, third semester BCom, Probability Distribution. Okay, and today my agenda, mathematical expectation and the expectation and variance of a random variable. So here in the till the last session have covered a few concepts which is related to the probability. Now which is the same concept which is going for the mathematical expectation. Okay, so here the expectation, what is exactly the expectation mathematical equations what we are able to identify. Okay, so we will get more clarity. Here mathematical expectation of the random variable. Random variable means when the data set, when any experiment is keep on going. So when we are trying to pick the number of outcome from the total outcomes, number of experiment what we are finding. So in this, let x be a discrete random variable with probability mass function of x. Here the experiment either it is dice related or coin related or playing cards, whatever it may be. So we need to identify certain experiment is very important. So there are two probability data set we are getting clarity. One is a discrete and continuous series. So the mathematical expectation of x is here E of x is nothing but your arithmetic mean. Okay. So how you can extend x from the x series, either which is related to coin or dice related. So whatever we are getting a result, so which is nothing but x. Okay, now take the total. Now you have to multiply with the respected probability. So each, in case of coin 1 by 2, if 2 coin 1 by 4. So like this result when we are getting, so you need to multiply with this. If x is a random variable which can be assumed any one of the value, for example, here for example, tile came means we are writing like 0, and one head, one tile you are getting means one head, because expected question which is related to head only. So we are not expecting a tile. So we are expecting a head. So one time again 2 coins if you toss, so the result of the 2 coins will be extending head tile. Here also we are getting one head, and the 2 coin result is 2 head. Now we are writing 2. This is nothing but your x series. Okay, so here x1, x2, x3, x4 like this, which is extending till the result. So where the respected probability, here in this case the probability total outcomes we are getting 4, no? So here 0, because we are not expecting a tile, we are expecting only for head. So in this case we are writing a probability is 0. We are out of 4 result, we are 1 by 4 we are getting. So if you are writing in the 0 fraction value 0.25 we can write. So here also one head we are getting, the total result will be 4. So here 2 head we are getting 2 by 4, again you can simplify, so 1 by 2 you are writing. So respected probability you need to multiply, that is a simple equation which is nothing but your arithmetic mean. Okay, till the end number of last probability. Then the mathematical expectation of x usually called expected value. Expected value. So you are try to multiply with the x series and probability. Okay, if you try to multiply, then we are getting the mathematical expected value. So x is generally denoted E of x. E of x, once again I am repeating it, which is nothing but your arithmetic mean. Okay, is defined E of x, how we are getting. See, if you try to take it together, summation, either we are try to do for horizontal or for vertical format. So in this case, which is looking like horizontal format, x into 1, x1 into probability 1. Okay, x1 here, x1, see the set of data, x1, x2, x3. So respected probability you need to multiply. So till the experimenter, which is the total last end result. Moving forward, so the result will be always you are expecting from the any experiment, either you are going for random, okay, so or clustered sample. So in this case, random variable which is related to the probability basis only. So the x is a arithmetic mean. When you are taking a e of x, which is nothing but your arithmetic mean, you must remember, okay. So for random variable x, the variance how we are writing, see x we know, okay, from the x series, from the experiment we identified there is x series, okay. If you try to go for variance, x square is required. So for that reason, the simple formula is the first one variance, we with the help of a x series only we are trying to convert for x square. So e of x square minus e of x. E of x is nothing but arithmetic mean, we already calculated whatever it is there, but we need to get for x square. So that's what the x series we need to multiply once again. So how we are getting x square into probability, respected probability you have to multiply, then only you are getting summation value, okay. Third one, for the random variable x, standard deviation, which is nothing but whenever you calculated variance, if you try to specify within the square root, okay. So inside the square root when you are writing, so here the variance directly based on the variance only, the standard deviation we can solve, okay. Otherwise we can extend like this also, both are same only, okay. I hope you cleared this concept. X square, with the help of x we are trying to go for x square, okay. So which is nothing but e of x is a sigma xi into pi. Pi is a probability, x is a result, divided by total probability. The total probability always which is giving for 1 only. The total probability, any problem, any experiment, the total probability will be always 1, okay. So here the probability, if you try to extend like this, which is nothing but your total probability, okay, the probability. So e of x, how we are getting sigma, because we need to take after calculation according to arithmetic mean, we need to multiply first, then after getting a multiplied, now we have to take for the summation of the total, okay. So after multiply x series and respected probability whatever you assigned. So here xi is nothing but a value of variable. Each and every experiment there is a value, like for example in this case to tile means 0 is a value, and one head one tile means 1 we are writing. One tile one head means 1 we are writing. This is nothing but your value, variable value, where 1 2 3 till the experiment last result. Here pi is nothing but the probability of xi, where okay, pi is a probability. Each and every experiment result we are getting a probability. We can identify in case of one dice 1 by 6 probability. In case of one coin 1 by 2 is a probability. Okay, if you are writing the fractions value 0.5 we are writing. So the mathematical expectation of a random variable is nothing but arithmetical average after taking the summation which is giving for arithmetic mean value. Okay, moving forward. So there is one question, so you can understand very clearly. There are two fair coins are tossed once. Okay, find the mathematical expectation. Two coins means you must remember there are 4 results. Okay, so whenever you are tossing a one time, so of course you are expecting a result here. So find the mathematical expectation of the number of head obtained. How many numbers because the question which is related to a head only. You are always expecting a head. Okay. So in case of two coin you toss, you are getting tile means you are not expecting, which is nothing but your x series is a 0. So here let x denote the number of head obtained, because the question is very transparently you can identify the which is related to head obtaining. So then x is a random variable which take the value from 0, 1, 2, because 0 is a 2 tile. Okay, because we are writing 0 because we are not expecting a head. That's what we are writing for 0. And second, there are for example tile head or head tile. Okay, so here also we are expecting head 1 tile, so 1 is a value. And last tile head we are when you are getting, so then you are writing 2 with the respective probability, because probability we already in this tabular format you can understand. See the x series whatever we are getting, so which is nothing but here I am writing here the same thing. Tile means because the question which is related to head, so we are expecting a there is no head, so that's what we are written 0. And second time when you're tossing, you're getting one head, one tail. So that's what, how many times we are getting. So here there are 2 times we are getting. So here head, tail, tail, head. Okay, last one head, head. So here in this case 2 times we are expecting at least one head. So that's what I have written. The probability is 2 by total outcomes will be 4. Okay, and 2 head when you are expecting the X series, your 2 head means you are writing directly 2 because you are expecting a 2 head only one time. That's what your written probability 1 by 4. Okay, so I hope you clear this one. So moving forward for the now mathematically solving, how we can solve the expected probability with the help of X series. So the mathematical expectation of the number of the head, because we tabular format already converted. So with the help of tabular format, we need to take the summation. Okay, either you are doing for vertical format or horizontal format, whatever it is maybe. So E of X, because which is question which is related to find out the mathematical expectation, which is nothing but arithmetic mean. Okay, so arithmetic mean formula what? Sigma X into P of X. Sigma X into P of X. Okay, if you try to multiply with each and every X series, now first X series will be starting from 0. Okay, the respected probability you need to multiply 1 by 4. Okay, now second one you are going plus. Okay, so 1 into the respected probability 1 by 2. So third X series will be 2 into 1 by 4. Now finally mathematical expectations, the answer arithmetic mean will be 1. Moving forward for next question. For the following probability distribution, find E of X, variance of X, standard deviation of X, E of X. What we need to do, according to the each and everything, we need to construct the table. The question which is clearly specified in the question, okay, the X series which is starting from the -1, 0, 1, 2. And the respected probability also clearly specified in the question: 1 by 5, 1 by 10, 3 by 5, 3 by 10 and 2 by 5. Now we need to find out E of X, which is nothing but arithmetic mean, and variance if you finding. Okay, and with the help of variance directly we can solve for the finding the standard deviation. And there is one more equation which is related to E of X. Whatever which is there, we need to construct the table according to what they are asking. Okay, so I have written one more time the X series whatever. Okay, the probability also I have written. The probability always you are getting 1 only. Okay, the total will be 1. So according to variance, we need to get E of X square is required. Okay, E of X square is required, and E of X square and E of X to the power of square, because we got this value with the help of questions directly we can do. So now we need to do for X square with the help of X series. Now whatever we are doing, so X square we are doing 1 into 1, minus into minus plus, 1 into 1, 1 directly, 0 into 0, 0, 1 into 1, 1, 2 into 2, 4. Okay, now according to formula basis only we are constructing. Now there is one more equation which is related to 2x minus 4 is required. So that's what one more time I am constructing. Now I try to do for the horizontal level. If you want, you can do for my vertical format also. So here 2x, x place I am writing 1, okay, minus 1. Okay, so I am here the 2x minus 4. Okay, see here 2 as it is I am writing. In the bracket I want to write for minus 1 because the minus sign is specified. Okay, again minus 4. Whatever the equation is there, I just want to simplify x place. I want to get the numbers, original numbers. Okay, if you try to go for here 2 into minus 1, minus 2. Okay, minus 4. Now how much we are getting? Minus 6 we are getting. Okay, so like this each and every x series we need to simplify. So in this case we are getting, so 2 into 0, 0. Okay, minus 4. Okay, here minus 4 we are getting, because anything if you multiply with the 0, so which is directly you can cancel. So directly we are writing minus 4. Okay, here same thing, 2 into minus 2. Okay, in the rest minus 4. Now we are getting minus 2. Last one 0. Now we need to simplify according to whatever the question is asking here. Find E of X. E of X, any X, if you multiply with the any particular probability, you are getting E of X. E of X, the formula is very simple here. I have already written here. E of X formula, X series sigma X. sigma x into p of x. Okay, now we got the x series directly value. So the first x series starting from the -1. So -1 into respected probability. Okay, if you try to go for respected probability, so -1. Okay, now second x value 0. Okay, so second x value 0. So respected probability 1 by 10. 1 by 10. Next value 1. 1 into respected probability plus second value, next value 2. 2 into respected probability 2 by 5. Clear? So here it is 1 by 5. Now if you simplify completely, if you simplify, you are getting 0.9. So moving forward for the x square with the respected probability. X square, we just know we find the value for x square value. So just 1. The formula is sigma x square into p of x respected probability. The first x square value 1, okay, into respected probability 1 into 5. Now plus second value x series x square value 0 into respected probability 1 by 10. So next x square value 1, okay, 1 into respected probability 3 into 5. Plus next x square value 4 into respected probability 2 by 5. If you simplify 2.1, you are getting. Now next, according to equation, we just now find for Ex, which is nothing but arithmetic mean. Now variance formula I have written here. So in this formula we got this 2 value. Okay, directly we can use this one only because the formula whatever it is there. Okay, so same thing. So the formula equation, again you need to go for 2x minus 4. Okay, 2x minus 4, we already got the value 2x minus 4 value. Okay, into respected probability only we are multiplying here. So the formula is sigma 2x minus 4 into respected probability. The first value 2x minus 4 value minus 6 into respected 1 by 5. Again second value minus 4 respected probability 1 by 5. Next 2x minus 4 value minus 2 respected probability multiply to 3 by 10. Last 2x minus 4 value 0 respected probability 2 by 5. If you simplify minus 2.5 we are getting. Now moving for variance. The variance formula we know here Ex value and Ex value. Directly we can take the final answer. Okay, instead of multiplying directly we can take here. So here Ex square value, here we are getting 2.1. So minus 2.1 into 0.1 to the power of square. If you simplify we are getting 1.29. Now standard deviation, how we are finding? Standard deviation, which is nothing but whatever we are getting from the variance, directly if you take the inside the square root, if you are writing variance, or you can extend like this also, both are. So if you know the value of Ex square, which is already calculated 1.29, so directly we can take for 1.29 directly because the variance we already calculated 1.29. So if you remove the square, you are getting 1.36. Moving forward. So there is one more question, okay, for the following probability distribution, find E of x, which is arithmetic mean, and one more equation, E 2x minus 4. Okay, and again you have to find out E x square plus 2 and variance and standard deviation, because the question which is given x series value minus 2, 0, 1, 2. The respected probability, they given fraction value 0.2, 0.4, 0.3, 0.1. So according to the information whatever it is given, we need to find out x square is required. Now we need to find out x square, and again you need to find out this equation. Now first with the help of x we are finding x square. Okay, again we need to go for second equations like 2x minus 4. Okay, and one more equations which is x square plus 2. Okay, so respected probability you just want to multiply here. So here in this horizontal format I have written x series, which is given in the horizontal format I have written for the vertical format. Okay, and the probability also given is horizontal format I have written for vertical format. Now with the help of x we are finding for x square. Why which is required for x square? Because in the equation also which is required, and even finding a variance also which is required. So that's what we need to go for the x square. So here minus 2 into minus 2, 4, 0 into 0, 0, 1 into 1, 1, 2 into 2, 4. Okay, now once we got the x square value, now we are going for the questions. 2x minus 4 which is given. Now we are not multiplied. Till now we are not multiplied with the respective frequency. We are just finding the value for 2x minus 4 and x square value. So 2 place as it is, okay, and first x is minus 2, okay, so the same sign minus 4 as it is you are writing. So plus into minus, minus 4, okay, minus 4, total minus 8 we are getting. Again second one, next x value 0. If you try to multiply with the 2 into 0, 2 into 0, 0, minus 4 as it is I am writing. So 2 into 1, 2. Okay, minus 4. Now which sign is more? Minus sign is more. That's what if you try to subtract, you are getting minus 2. 2 into 2, 4. Plus 4, minus 4 is cancelled. Directly we can write for 0. Now according to one more equation, x square plus 2 is required. X square we just know we calculated. So x square plus 4. 4 plus 2, 6. 0 plus 2, 2. 1 plus 2, 3. 4 plus 2, 6. Okay, now we got the value whatever which is related to the question. Now we need to multiply with the x into probability, x square into probability, 2x minus 4 into probability, 2x square plus 2 into probability. So once you are finding, then we are able to simplify. Now we are multiplying first x value minus 2 into respected probability 0.2, we are getting minus 0.4. Okay, next 0 into respected probability, anything if you multiply 0, 0 we are getting. Next 1 into respected probability 0.3 if you multiply. So the same procedure after taking this total which is nothing but your arithmetic mean we are getting. Okay, now moving for next one, x square is, we already calculated x square, now we are trying to go for x square calculation, x square into probability. X square 4 into 0.2 we are getting 0.8. X square value 0 into anything 0, 0. Next x square value 1 into 0.3 we are getting 0.3. Last x square 4 into 0.1 we are getting 0.4. Okay, last if you add together we are getting 1.5. 1.5 if you take together E of x square which is required for the variance and standard deviation. Okay, now moving for 2x we already calculated minus 8 into 0.2 we are getting minus 1.6. Next minus 4 into 0.4 we are getting minus 1.6. Minus 2 into 0.3 we are getting minus 0.6. Okay, last one 0 into anything multiply 0. If you take together we are getting minus 3.8 which is nothing but E of 2x minus 4. Now last one, we got the value for x square plus 2 respected probability, just multiply. So the first value 6 into respected probability 0.2 we are getting 1.2. Next 2 into 0.4 we are getting 0.8. Next 3 into 0.3 we are getting 0.9. So like this if you multiply, if you taking together, now we can simplify this equation. Okay, so next whatever we got, final answer we are writing like this. See 0.1, 1.5, minus 3.8 and 3.5 we are writing in the equation format. Okay, the first value, second value, third value, fourth value. Now just we need to find out the variance, because the variance formula ex square value 1.5. okay, directly 1.5, and ex square value 0.1, ex value 0.1. okay, so here the whatever we are getting the value which is related to simplifying the value, so finally we are getting 1.49. Now the same answer if you try to remove the square root, directly we can write 1.49. so after remove the square root we are getting 1.22. So next, moving one more coin, there is one more question which is related to 3 coins ABC are tossed at random once, obtain the expected number of heads. Okay, which is related to number of heads only, the frequency distribution of the number of head. Okay, so which is the question whatever they are asking, because A one coin, B one coin, C one coin. So number of head whatever we are tossing, okay, from this tossing what result we are expecting, we are writing like this. So this answer how we are get to know, because of see the 3 coins, the 3 coins simultaneously when tossed. The first time you are getting tile because we are expecting a result for head. That's what in the possibility result we are writing 0. And second time when you are tossing 2 head tile 1 head because at least 1 head we are expecting. Third time when you toss we are getting a tile head tile head tile, so at least 1 head we are getting. So the fourth time when you are tossing 2 tile 1 head is coming, at least 1 head. So 1 2 3 4 5, fifth time when you are tossing 2 head 1 tile is coming, 2 time we are getting. And sixth time 2 head we are getting, that's what 2 times we are writing. So seventh time when you are tossing you are getting 2 head, so directly we are writing 2 head. So last time when you are tossing at least you are expecting a 3 head for last experiment. Okay, toss. Now we need to go for the, if the calculated whatever it is given, so we are writing like the, if the calculated arithmetic, if you want to calculate, so yes, which is starting from 0, the maximum number 3, so we are writing ascending order 0 1 2 3. Okay, 0 how many times came? Only 1 time. So 1 how many times came? 3 times came, so 3 we are writing. 2 how many times came? 3 times came, so we are writing 3. So 3 only 1 time. So if you take together we are getting n value is 8. So which is nothing but discrete group data is now we are just converted with the help of experiment. Okay, now we need to find out f into x multiply. Okay, first value 0, 3 into 1 3, 2 into 3, 2 into 3 6, 3 ones 3. If you take together we are getting 12. Now we can simplify the arithmetic mean. Sigma fx divided by n, 12 divided by 8, you are getting 1.5, which is your nothing but arithmetic mean, which is always equal to the first equation. Okay. Now mathematical expectation of x, E of x is equal to sigma, okay, from the x series, because we already converted x series, and respected probability because each and every coin the probability also which is given. Okay, how many times we expected the total result. See the probability if you are writing, the first one is 1 upon 8. So second one 3 upon 8. Next one more 3 upon 8. Last one 1 upon 8. So this is your probability. So we are trying to go for solving the equation. Okay, so the first experiment is a 0, x value 0, respected probability 1 by 8. Okay, plus second experiment is 1 into the respected probability 3 by 8. Third one 2, respected probability 3 by 8. Last one 3, x value 3, respected probability 1 by 8. If you simplify, finally we are getting, say 0, first one 0, 1 by 0 into anything we multiply 0. Now next 1 into 3, 3 by 8. 2 into 3, 6 by 8. 3 into 1, 3 by 8. So if a plus and minus sign is there means now we need to take the common LCM. 8 cancel 3, 8 cancel 6. Okay, 8 cancel 3. Now if you take together we are getting 12 by 8. So if you simplify 1.5. So which is nothing but arithmetic mean is 1.5. Okay, whatever we are getting with the help of discrete group data. Last slide till now which is related to mathematical expectation, now which is related to random variable. Okay, so when the random variable which is completely depending on the what kind of experiment. Okay, so logically by random variable we mean a real number of x, because any experiment, so you need to identify there is an x value. So here x associated with the outcomes of a random experiment, because outcome, see without a x series value we can't go assign the any probability. That's what we need to depend on the x value. So from the outcomes only. So it can take any one of the various possible value each with a definite probability, because any experiment we are trying to conduct, you have to get a probability. So you are assigning a probability. In case of one coin 1 by 2 or 0.5 we are assigning. In case of one dice we are writing 1 by 6, 0.16 we are assigning. So like this the assigning which is completely based on the x series. Suppose two fair coins are tossed, the same space is nothing but see the 2 times we are getting, at least 1 time head we are getting, one time we are heading, we are getting 2 tiles we are getting. So here the assigning, if you are writing 0 and 1 head, 2 head. So which is nothing but with the experiment only we identify X series value. Okay. So if every sample point in this sample space number is assigned is below, so here the sample point which is nothing but your X series and number which is nothing but frequency. How many times you are expected? Only one time from the experiment. So one head, one time. How many times you are expected? You are expected only one time. Okay, and same thing. Head and tile. Oh, you are getting one time only. 2 head. When it is appeared 2 times you are getting. So the frequency we are identified. So here the assigned number of indicate the number of head obtained in the each, because each and every time. So there are 3 possibility for getting a head, at least one head. So there is no head one time, which is non-appearing head. So the number of head be denoted by X in the functions on the sample space. The number of appearance we identified. So it can take the value for 0 and 0, 1 and 2 with respected probability. See the total outcomes when you are writing, there are 4 chances. Okay. So the first possibility when you are writing, see the first one tile we are writing like 0 divided by 4, which is nothing but 0, but that's what the probability is not getting, because the question which is related to you are expecting head. So second time here when you are writing the total outcomes we are getting 1, 4. Okay, now we are assigning means 1 by 4. From the total outcomes only we are assigning the probability. See, 1 by 4 and 2 by 4 and 1 by 4. So here according to the experiment. Now when we are writing a random probability function, so you need to write a capital letter which is always for the, which is related to the experiment. So which is now first we are taking the numbers 0. Okay, the second, how we are writing the probability of there is no head, so there is 1 chances. Okay, 1 by 4. So the probability of getting at least 1 head, so P of X is equal to 1. So there is 1 head, 2 times you are expected, that's what 2 by 4, or you can write 1 by 2. Okay, simplify. So at least there are maximum head. Okay, the 2 head when you are expect P of X is equal to 2 head, so you are expecting only 1 time, that's what 1 by 2. Okay, so X is called for random variable. You without X value you can't go for the calculation, you can't go for doing a probability. So the probability which is completely you need to identify the X value. So there is one standard definition, random variable is a function, okay, so which assign a real number. Okay, real number means X. So every sample point in the sample space. So any X value we are assigning 1 by 2 or 2 by 4. Okay, based on the experiment, 2 coin, 3 coin, any numbers. Okay, any experiment. So which is a real number we identified. Okay, moving forward. So here there are 2 types of random variable we are identified here. So the first one are discrete random variable and continuous random variable. Discrete means which is nothing but X series. Okay. So there are 2 types. One is ungroup and group data, because whatever you studied in the first chapters, so which is related to the measure of central tendency or measure of dispersion, whatever you are trying to do, the data set is very important. So we have identified there are discrete random variable and continuous random variable. Continuous random variable where you are able to identify lower limit and upper limit, open-ended, close-ended. Okay, so there is a width we are getting. So there are 2 types of, okay, under discrete random variable in shortly we are writing DRV, okay, and continuous random short we are writing CRV. Okay, first one, discrete random variable, the set of data which is like a horizontal or vertical. Okay, so we need to get an idea, we need to get a X value if you want to go for further calculation. Okay, so a random variable X which take the specified value X1, X2, X3 till Xn, the number of result what you are expecting from the experiment. So with the respected probability, because each and every experiment is giving a different probability value. In case of coin 1 by 2, in case of dice 1 by 6 we are getting. So like this the probability also we are getting from the experiment. Okay, we are assigning, we are getting the experiment, which is nothing but P1, P2, P3 till the last outcomes. Example, let X denote the number of obtained while throwing a fair die. Okay, the die, because there are 6 ways we are getting. For example, if you are writing in the X series, X1 1, okay, X2 we are writing 2, because there are till 6 numbers we are getting. So 1, 2, 3, 4, 5, whatever it is there here. See, then X is a random variable taking the specified value, because unless you are not identified the X value, now we can't go for further calculation. So 1 to 6 phase we are getting the X series, which is nothing but X series with respected probability 1 by 6. Each and every phase the probability is assigned for 1 by 6. Now continuous random variable, a random variable which assume all the possible value in its range. See, 0 to 10 or 0 to 9, or if you try to go for open inclusive or exclusive, or 5 to 10. So whatever the range we are getting, which is nothing but the continuous random variable. Okay, so here let X denote the marks obtained, because most of the questions which is related to marks obtained, okay, number of employees, the group of peoples, where you are exactly finding a range. If you are finding a range, the simple formula of finding highest minus lowest value, the range. The group of student in a examination, the X is a continuous random variable, because in this case we are able to get a range difference we are getting, highest minus lowest. So random variable are denoted by capital letters, capital letter like X, Y, Z, okay, till etc. If X is a random variable, okay, the value assumed by the random variable of X, which is denoted by small letter Xi. Okay, so moving forward. Now, here there are two major types we identify. One is a discrete random variable, okay, so which is nothing but probability mass functions, which is related to discrete random variable basis. Okay, now probability density functions, which is nothing but continuous random variable. Okay, so here we are finding a range. Okay, in the probability mass function, let X be a random discrete random variable, because of with the help of a random variable, with the help of discrete, we are trying to go for assigning a probability. And P of X, how we are writing the probability mass function. Probability mass functions P of X be the function such as P of X, how we are writing capital letter X when you are writing, which is a random variable. Okay, X is a functions, okay, P of X is equal to P of X is equal to X. Okay, in the previous slides you got capital letter X, Y, Z, which is nothing but random variable. Okay, then P of X is a probability mass function, because under discrete method we are trying to go for calculating using a probability mass functions. So of X, here P of X is always greater than or equal to 0. Your probability we are getting total 1, but X, when you try to go for experimental, which is depending on the discrete value or X value, so which is always going for the value which is assigned. For example, 0 and 1, 2, so which is equal, or first equal means 0. Okay, now in the last problem we identify there are 2 tiles, means we are getting 2 tile. Okay, 1, 2 head times head tile head. Okay, plus 2 head 2 times. Okay, this is your experiment X value. So which is always P of X is equal to greater than or equal. Equal means 0. Or greater than means these two cases will be greater than X series value. Now probability of X, which is always that the probability total will be always 1. This is which is related to probability mass function. Now moving for probability density function, which is related to continuous random variable, where you are identified range. A similar function is defined by the continuous random variable of X. Okay, so in this case it is called a probability density function, which is symbolically represented F of X. Okay, F of X. Keep on watch for next section. Thank you.